Okay, welcome back to Unit 6, Topic 1. This is covering standard form versus vertex form. So in this video, I'm going to specifically cover standard form. I'm not going to go through the chart. I would expect you to read through the chart, but a couple things on the chart that we're definitely going to need to make sure that we are very familiar with is this part of the function, or this part of the vertex, okay? That part of the vertex is the x value or is the value that we use for our axis of symmetry. So it's a very nice, neat formula that we're going to use. And then once we get that value, we're going to plug it back into the function so that we get the y value of the vertex. Because here in standard form, it will look like the following. You're going to have an a value, you're going to have a b value, and it might not all be together at one on one side. You may have to manipulate it so that you get ax squared with the bx with c all on the same side. And let me backtrack that color because like my B value needs to be pink here. And my C value is blue. Okay, so now what we're going to do is we're going to start with just go straight to example 2. We're identifying the following components of the quadratic just from the standard form function. Identify the vertex, the max or the min, the axis of symmetry, the y-intercept, and the direction of opening of the quadratic function. So I like to start with the direction of opening just because it's already there in front of me. So a couple things I'm going to notice is the a is always in front of the x squared. So my a is positive 3. My b is negative 6. It's always with the x term. That's my linear term. And then my c is positive 1. Okay, now the direction of opening is directly based off of the A value. So I'm looking right there at the A value. So let's go green there. So when I look at that A value, if it's positive, then it's opening up. If it's negative, it's opening down. Since it's positive 3, that means this is opening up. Okay, and if you think about the graph then, that means it's like this, right? And so the lowest it's going to go is going to be what we call the minimum. So I know right now it has a minimum, and the minimum is going to be the y value of the vertex, which we'll get that here in just a minute. So all I know is it's a minimum at the y equals, and then I'll figure out the value. We'll also cover what the axis of symmetry is. We'll find that first because we're going to need it in order to find the minimum. So the axis of symmetry is at x equals, and it's going to be the x value of the vertex. And then to find the vertex is directly based off of that function that I highlighted above. We have negative b over 2a. So we're going to say the vertex is at some point. We're looking for the x value of the vertex. So we're going to go negative b over 2a. Well, negative b is negative 6 over 2 times 3. And a negative times a negative is positive, so you get 6 over 6, which is equal to 1. So the vertex is at 1 something. So the axis of symmetry is at x equals 1. Now what we'll do is we'll plug in the 1 into the original function in order to get the minimum value. So 3 times 1 squared minus 6 times 1 plus 1. Well, 3 times 1 squared is 3, minus 6 times 1, which is minus 6, plus 1. And then when you do the math there, 3 minus 6 is negative 3. Add 1, we get negative 2. So we found the y value of the vertex, which is negative 2, which means that's the minimum at y equals negative 2. Now, the last part that we need is the y-intercept. And it's always going to be, since we're in standard form, as long as you have all three parts together on the same side, then, or wherever the x squared part is at, as long as your constants with the x squared, you already know what the y-intercept is. So in this case here, it is 0, 1. And that is finding all of the attributes of the quadratic given standard form. So this function was specifically standard form. Okay. In the next video, I will cover vertex form.